Hello, my wonderful Algebra 2 gems. Today is our final video. It's our week 8 video. It's our study guide for chapters 8.4 to 8.6 on normal distributions all the way through some probability. Just as a reminder, I don't know what day you're watching this, but you should be watching it hopefully Monday, May 18th, but our quiz is going to be on Thursday, May 21st, just so you're all aware. Other than that, though, I do just want to say, I wish there was a, do I know how to flip this? No. Can I flip this? No, but I can go like this. Am I in it? I hope so. Okay, I just want to say that thank you guys for a really great year. I've had so much fun with you guys, and I hope that you've had a great time too. I'm sorry that this is kind of like how we have to say goodbye to one another, but it's been a really fun year. Loved being with every one of you, and I hope that you guys have a really great summer if I don't get a chance to talk to you again, okay? So kisses to everyone. Okay, so let's get ourselves going now on our video here. Okay, so we're gonna get started. We're gonna do some review questions. Hopefully you're gonna feel really confident with these, and then you'll have your quiz on Thursday the 21st, and you'll have 2 days to do it as per usual. So let's jump right in. Number 1. Kate is randomly choosing a date in the month of August. What is the probability that she chooses a 2-digit number or a prime number? Okay, so first thing is I have to say, okay, in August, how many days do we have? I have 31 days in August. Okay, so what's the probability that she chooses a 2-digit number? Well, you have to count. You have to say, okay, from the 9th to the 31st would be 22 days. Okay, that's from the 9th, or sorry, 2-digit would be, the 10th, excuse me. I was like, wait, that doesn't sound right. 10 to the 31st, or a prime number. So I need to also pick the prime numbers that start before the 10th. So that would be numbers 2, 3, 5, 7. I don't want to go up to 11, right? Because 11's counted in those 2-digit days. So there's another 4 days here. So in total, I have 22 days plus the 4 days. So my favorable probability is going to be 26 days out of 31 total. And I can't simplify that any further, so that's my whole answer. Number 2. Eric is randomly choosing a card from a standard deck. What is the probability that he chooses a card that is red and a multiple of 3? Okay. So the only ones that are multiples of 3 are 3, 6, and 9, right? Because once you get to like king, queens, and jacks, right, those are not multiples of 3. Now, I have a 3, a 6, and a 9 that can be a diamond, because that's a red card. And I have a 3, a 6, and a 9 that could be a heart. It's also a red card. So in total, that is 3 plus 3, that is 6 total. Out of the whole deck is 52, and then I can reduce that. I can divide them both by 2, so I get 3 over 26 is the probability that I choose a card that is red and a multiple of 3. Number 3, one of the 50 states is chosen at random. What is the probability of not choosing a state that begins with the letter N? So remember, not choosing is a conditional probability. So what I'm going to do, or excuse me, a complement. So what I'm going to do is I'm going to think of all of the states that start with the letter N. Well, there are, if you don't know, you might have to Google it. There are 8 states that begin with the letter N. We've got Nevada, Nebraska, New Hampshire, New Jersey, New Mexico, New York, North Carolina, and North Dakota. That's 8 in total. So to figure out the complement, though, choosing the state that does not begin with the letter N, I'm going to take the number 1, right, because that's my whole percentage, and I'm going to subtract 8 out of 50, which is my favorable outcome. Now, remember, 1, I can rewrite that, instead of 1, I can rewrite that as 50/50ths, right, because that's a whole, right, it's like a whole piece of a pizza. You have all 50 slices of the 50. So 50 minus 8 gets me to 42 out of the 50 states, and then I can simplify that. I can divide them both by 2, so I would get 21 out of 25. Okay, so anytime you see the word probability of not, you know you are doing 1 minus the favorable probability because that's what it's asking me to do. Number 4, Tony's wallet contains 6 $1 bills, 4 $5 bills, 2 $10 bills, and 3 $20 bills. If Tony randomly removes a bill, what is the probability that it is at least $5? So that means $5 and greater. First thing I want to do is figure out how many bills does he have total. He has 6, 4, 2, and 3, which in total is 15. And I want to know what's the probability that it's at least 5, so that means 5 or greater. So he's got 4 $5 bills, 2 $10 bills, and 3 $20 bills. That is a total of 9 out of the 15. And then I can reduce that. I can divide them both by 3, so I get 3 out of 5. Just some simple probability events. Okay, number 5. A number 1 through 30 is randomly selected, followed by a letter from the word target. What is the probability of choosing a perfect square, then the letter T? So this is a compound probability, right? Because you've got 2 different things that are happening. Now, I have to decide if it's an independent event or a dependent event. Independent means it's 2 events that have nothing to do with one another. So if I randomly select a number and then a letter from the word target, me randomly selecting a number does not have any indication on what letter I'm going to choose. So these are considered independent events. And when they're independent events, you just multiply the probability of the first one happening times the probability of the second one happening. So first thing I need to do is it says the probability of choosing a perfect square. So I actually have to know what my perfect squares are, right? Between 1 and 30. My perfect squares would be 1, 4, 9, 16, 25, and I stop there because if I go to 6 squared, right, I get to 36, which is greater. So I have 1, 2, 3, 4, 5 perfect squares out of 30 numbers times the probability of choosing the letter T in the word target. There's 2 letter T's out of 1, 2, 3, 4, 5, 6 letters in total, and I multiply those events together straight across. So if I do that, I get 10 out of 180, and I can divide them both by 10. I get a 1 out of 18 probability. Okay, number 6. Carter's handing out Valentine's Day cards to his friends. He has 8 Batman cards, 12 Superman cards, 5 Captain America cards, and a bag. What's the probability that the first 2 he chooses are Batman? Okay, so now I have to decide, is this independent or dependent? Now, if he takes one out, it doesn't say that he replaces it, he keeps it out. So because of that, that's gonna change the number of chances I have for the second card. So these are dependent events. So the chance that the first time I pick a Batman card would be 8 out of the total number of cards, and in total he has 8 plus 12 plus 5, so he's got 25 cards total. Now the second time he chooses it, if he takes that one out, he now only has 7 left, and instead of there being 25 cards, he only has 24 cards. So I can multiply straight across. You can reduce before you multiply, it's up to you, right? You could take out the 8 from here and the 8 from here. Which is fine, you can do that, or you can just multiply straight across and then reduce at the end. It's up to you, whatever you want to do. I know that these 2 both get divided by 8 in order to reduce them, so I get 7 out of 75. I'm done. All right, for questions numbers 7 and 8, a bag contains 25 red chips, 18 blue chips, and 29 yellow chips. A chip is selected, replaced, then another chip is chosen. Find each probability. Okay, so because it says it's been replaced, that means these are independent events. Right, I'm not changing the number like I did over here for this problem, how many I have. I'm putting all of them right back in. So the probability of me picking out a blue chip is 18 out of the total number of chips. The total number of chips is 25 plus 18 plus 29, which gives me 72. So that's the probability of picking a blue chip times the probability of picking a red chip. I put it back in, right? So it's 25 out of 72. Again, you can reduce first or you can reduce last. It's up to you. So if I multiply straight across, I get 450 out of 5184. And both of these are divisible by 18. So my answer is 25 out of 288. My next probability is probability of a yellow, then a blue. So I've got 29 yellow chips, so 29 out of the total of 72, times I've got 18 blue chips, again out of 72 because it is replaced. So I just multiply straight across. Again, if you want to reduce first, you can. I sometimes do, sometimes I just wait to the end. It just kind of depends on how I'm feeling. I know that both of these are divisible by 18. So I get 29 out of 288. Again, another independent event. Now, for questions 9 through 10, a box of pizza contains 3 cheese slices, 7 pepperoni slices, and 5 supreme slices. Mark randomly chooses a slice, eats it, then chooses another. Find each probability. So because he's eating a slice and he's not replacing it, these are considered dependent events. So my numbers are going to change. The total numbers that I have are going to change for each one, right? Because you're taking one out every time. Okay. So probability, first thing I want to do is I just want to figure out how many slices he has. He's got 3, 7, and 5. So that's a total of 15. So if he does cheese first, then supreme, make sure you always go in order that's listed. Cheese first, he's got a 3 out of 15 chance for that. Times supreme, he's got 5 slices of supreme, but remember he's eaten 1, so he no longer has 15. Now he only has 14. Okay. You've got some choices here. I know 3 times 5 is 15. And actually, before I even go over here, I know this is 15 times 14. 15s will cancel. So my answer is 1 over 14. Right, so you can do it first, you can do it last like I do over here, however you want to simplify it. Next one, probability of picking 2 pepperonis. So go back to the beginning. So he's got 15 slices in total. If he picks 1 pepperoni first, there's a 7 out of 15 chance that he's going to have it. Times the next time, he's now going to go down to only 14 slices because 1's gone. And if he already took out a pepperoni, he no longer has 7. Now he has 6. So I'm going to multiply straight across. And I know they can both be divided by 42. So I get 1 over 5. So being very careful that you understand the difference between dependent and independent. If they are being replaced, then they are independent events. If they are not being replaced, then they are dependent events. Okay. Now, next problems. We are going to label our normal distribution curve, and then we're going to answer the questions that follow. So remember, if it is a normal distribution curve, before I do anything, I'm always going to do my percentages first. Okay, so I've got, I know in the center here, this is where my mean goes. This is 1 standard deviation, 2, and 3. This is -1, -2, -3 standard deviations. My percentages are always the same. 34.1, then 13.6, and then 2.2, and then 0.1. Okay, so in the center goes my mean. So the problem says the ages of 32 recruits in a police academy are normally distributed with a mean of 27 and a standard deviation of 2. So that means the average age right in the center is 27. And each standard deviation away is 2 years either greater or less than the 27. So I'm going to add 2 on the right and I'm going to subtract 2 on the left. So I go to 29, 31, 33. And then if I subtract a standard deviation, I'm at 25, 23, and 21. Okay. Now, question 11 says, what percent of the recruits are between the ages of 23 and 27? So go from 23 to 27. These two are my percentages, so I just add those two together. And if I add those two percentages together, I get 47.7%. Easy stuff. Number 12, what is the probability that a recruit is at least 31 years old? So that means 31 years old or greater. So from here and greater, I'm going to add those percentages together. It's very tiny. It's 2.2 plus 0.1. That's 2.3%. Last question. Approximately how many recruits are at most 29 years old? Okay, so 29 years old is here, but it's not asking me for a percent, it's asking me how many recruits. So the first thing I want to do is figure out the percentage up to 29. So I'm just going to add together 34, 34.1, 13.6, 2.2, and 0.1. Okay, so I'm adding up all of these. Right, at most, 29. So it's everything up to 29. If I add up all those percentages together, I know I'm going to get 84.1%. Now, it's 84.1% of the total number of recruits that I have, which is 32. So, of means multiply. I'm going to multiply this times this, but when I write it, I'm going to put it as a decimal. So I'm going to move it over 2 places. I'm going to do 0.841. Right, because I moved it 2 over, times 32. If I do that, 0.841 times 32, I get 26.912. Now I'm talking about number of recruits or number of people. I can't have 0.9 of a person, so my answer is about 26 recruits. I want to round down for this one, right? Because I'm saying I don't have a whole person just yet, so you always round down. All right, next one, number 14. The blood pressure of a group of adults is normally distributed with a mean of 122 and a standard deviation of 13. If Mina's blood pressure is 108, find her z-score. Okay, so z-score tells me how far away I am from the average, right? How many standard deviations away I am. So to find the z-score, you always take your data point, x, subtract the average, the mu, and divide it by your standard deviation, sigma. So I know Mina's blood pressure is 108. Subtract the average, the mean, is 122. And then I divide it by the standard deviation, which is 13. And now it's just some pretty easy math, right? If I subtract these, I get negative 14 over 13. And then if I divide those, I get my z-score is about negative 1.08. So that means Mina's blood pressure is -1 standard deviations away from the average. So that would be somewhere like, if this was where her average was, she would be 1 standard deviation away. So she'd be below it, which makes sense because her blood pressure is 108 and that is smaller than 122. So her answer should be a negative. Number 15. The daily balance of a checking account over the course of a month is normally distributed with a standard deviation of $84.10. If the balance in the account on a particular day was $317.34 with a z-score of -2.4, find the mean balance. Okay, so it's similar to this last one over here. I'm using the same equation, but I'm just plugging in different parts to that equation. I know the z-score in this problem. My z-score is -2.4 equals. Next part would come my data, the set of data that I have for that day. And on that particular day, my balance is 317.34 minus The next part is my mu, my average. I don't know what my average is, right? Because that's what it's asking me to find. So I'm going to leave it as mu over my standard deviation is $84.10. Okay, and now I'm just going to solve for mu. So the first thing I'm going to do is I'm going to get rid of the divided by 84.10 by multiplying by 84.10. I'm going to do it on both sides. Oops, going to go off to the next problem a little bit, but that's okay. All right. If I multiply 84.10 times negative 2.4, I get negative 201.84 minus mu. Okay. Next I'm going to do is I'm going to get the mu by itself, so I'm going to subtract 317.34 from both sides. I'm going to get a negative number. That's okay. I get, I'm going to run out of space here. Woo! I get negative 519.18 is equal to negative mu. And then to get rid of the negative signs, I divide them both by a negative 1, right? So my answer is that the average is $519.18. There's my me, my average. Easy stuff, right? You're just plugging into an equation and solving for different pieces, essentially. Okay. Number 16. The length of a certain fish species is normally distributed with a mean of 15 centimeters. If a fish in this species is 18.8 centimeters with a z-score of 1.9, what is the standard deviation? So I'm using the same equation, I'm just plugging in different values. I know my z-score, it's 1.9. I know what my average is, or my particular fish the data is. The species is 18.8 centimeters. Minus, my average is given to me, it's 15, over standard deviations, what I'm solving for. So the first thing I'm going to do is I'm just going to subtract those two right there, right on top, to make this a little bit easier for myself. I get 3.8 divided by standard deviation, sigma. Now to get the sigma by itself, I'm going to multiply both sides by sigma. So I get sigma times 1.9, this cancel, equals 3.8. And then to get sigma by itself, I divide both sides by 1.9. So my final answer is that sigma is equal to 2. That's my standard deviation. It's actually 2 centimeters, right? Because we're talking about the length of the fish in centimeters. Number 17. The number of visits to the gym each year by the members at InFit is normally distributed with a mean of 97 and a standard deviation of 25. If Kurt's z-score is negative 1.8 and Mindy's z-score is 2.4, how many more times did Mindy visit the gym than Kurt? Okay, so we're going to do Kurt first. Okay, I'm just plugging in my information again into this z-score equation. So I know Kurt's z-score is negative 1.8. Equal to, now I don't know how many times he went to the gym, right? So that's my data point, so I'm just going to keep it as x, minus the average number of times was 97 divided by my standard deviation of 25 times. Now I'm just solving to get the x by itself. So the first thing I'm going to do is I'm going to multiply both sides by 25. I get negative 45 equals x minus 97. And then to get the x by itself, I add 97 on both sides. And I get that Kurt went to the gym 52 times. Okay, that's great. Now I want to figure out, all right, there's Kurt. Let's figure out how many times Mindy went to the gym. Okay, so Mindy's z-score is 2.4. I don't know how many times she went to the gym. I know the average is 97, and I have a standard deviation of 25 times. Do the same thing. I'm going to get the x by itself, so I'm going to multiply both sides by 25. Oops, sorry about that. So I get, what is this? 60 equals x minus 97. And then I add 97 on both sides. I get that Mindy went to the gym 157 times. So the final question says, how many more times did Mindy visit the gym than Kurt? In order to figure that out, I'm going to take the number of times Mindy went, I'm going to subtract the number of times Kurt went, and that's going to tell me how many more times Mindy went than Kurt. So Mindy went to the gym. So if I subtract those two, I get 105 more times than Kurt. So clearly, Mindy is the one that is in shape. Kurt is not. Okay. Number 18. A random sample of 2,500 students found that 21% reported their favorite class as math. What is the margin of error for the sample? Round to the nearest percent. Now, if we go back to margin of error, we have to decide if this is categorical or quantitative data. Because it's telling me their favorite class was math, that is categorical data. If you have categorical data, the only thing you're going to do in order to figure out the margin of error, or MOE, is you're going to take 1 divided by the square root of your sample size. So if it's categorical, it's really easy. My sample size was 2,500 students. So if I take the square root of 2,500, I get 50. So I just divide 1 over 50. My margin of error, so this gives me 0.02. So if we're talking in percent, my margin of error, remember, a margin of error can be a positive or a negative. It can either be above the mean or below the mean. So my margin of error is plus or minus, and this would be 2%. Or you can say plus or minus 0.2. It doesn't really matter how you describe it. You can leave it either way. Up to you. But because we're talking really about percent, you should leave yours in percent as well. Number 19, excuse me. The nationwide mean score of scholars on the ACT is 24 with a standard deviation of 3 points. A random sample of 210 scholars was used. Determine the margin of error and the range of reasonable means. Okay, now when you're looking for margin of error, you have to determine, is it categorical or is it quantitative? We are talking about a score on a math test, so this is considered quantitative data. Because it is quantitative, in order to find the margin of error, I have to do 2 times the standard deviation, and then I'm dividing it by the square root of my sample size. Okay, so if you're ever given the standard deviation, right there, standard deviation of, you have to use this equation. That's a pretty easy way to figure out if you're going to use categorical or if you're going to use quantitative. Okay, so my margin of error becomes 2 times my standard deviation, which is just 3, all over the square root of my sample size, which was 210. So 2 times 3 gives me 6. Square root of 210 is about 14.49. So my margin of error, what's it over here, is approximately plus or minus. We're going to leave it as a decimal because we're talking about points. It has nothing to do with percentages, so we're going to leave it like that. So my margin of error is plus or minus 0.4 points. So in order to find my range of reasonable means, I'm just going to put ranged. My range of reasonable means, I'm going to take the average score, okay, whatever the mean was, and I'm either going to add or subtract the margin of error. My average, my mean score was 24. So I'm going to take 24, I'm going to add and subtract my margin of error, which is 0.41. So my range of reasonable means is between, so if I subtract first, it has to either be between 23.59 and 24.41. And we're talking about points or scores on the ACT. Okay, so it's saying that with the margin of error, my range of data that my people or my scholars should get from is between 23.5 and 24.4 on the ACT. All right, just about done, just a few more. So close. John scored a 78 on an exam with a average or a mean of 67 points and a standard deviation of 11 points. Kim scored an 82 on an exam with the average of 72 and a standard deviation of 14 points. If both exams had normally distributed scores, what was the z-score for each student? Who did better on their exam? Okay, so let's start off with John. First thing we're going to do is figure out what John's z-score is. So we take his score on his exam, which was a 78. We subtract the average, which was a 67. And then we divide that by the standard deviation. Okay, so if I subtract, that gives me 11 over 11. Okay, so John's z-score is 1. That means he is 1 standard deviation away from the average. Now let's do Kim. Okay, Kim scored an 82. So I should put an equal sign here. Minus the average of Kim's test was a 72. And the standard deviation was 14 points. If I subtract... 10. Come on, Mr. Nassau. I get 10 out of 14. And if I divide that, I get that Kim's z-score is up, we'll put approximately because it's a decimal. Her z-score is about 0.71. So this means John scored 1 standard deviation above the average. Kim scored 0.71 deviations above her average. Now, John's z-score is higher. Because John's z-score is higher, he is further away from the average. He is higher than Kim is from her average. So John is doing better relative to his exam because his standard deviation score is higher than Kim's standard deviation or z-score. So John's score, I'm not going to rewrite that whole thing because I just said it, but John's score is better relative to his exam. Right, because his z-score is 1 standard deviation above and Kim's is only 0.7 above. Now, if John's was like a negative and Kim's was 0.7, well, that means Kim would have done better because her z-score was higher. So the higher your z-score is, depending upon what the question's asking, but if I'm talking about a test, the higher your z-score is, the better you did on your exam. Okay, number 21. Suppose an event occurs X times in a sample size of N. Find the sample proportion and the margin of error to the nearest percent. Okay, so the first part is just finding the sample proportion. Sample proportion means the number of times it occurred out of the total. So that's a super easy part. I'm just going to make a fraction. 75 out of 450. If I do that, out of 450, I get about 0.16, the 6 is repeating. So if I turn that into a percent, I get about 16.6 repeating percent. But then it does, oh no, nope, sample proportion, that's fine. That's my sample proportion. I am asked to round the margin of error, though, to the nearest percent. Now, to find the margin of error, I am not given the standard deviation anywhere in this problem, so you must assume that it's categorical. So because of that, you're going to use the equation for margin of error of 1 divided by the square root of your total sample, which was 450. So I get square root of 450. It's 21.21, and then I do 1 divided by that. Okay, so I get 4.7. Okay, it's about 4.7, but it asks me to round to the nearest percent, so I'm going to say my margin of error is approximately 5%. Okay, next one, sample proportion first. I have 23 times out of 2,500. Okay, that is approximately 0.0092, and if I change that into a percent, I get 0.92% for my sample size. My margin of error, I'm going to take 1 divided by total sample of 2,500. No, the square root of 2,500 is 1 over 50, I believe. Should just check that. Yep. 1 over 50 is 0.02. And then if I change that to a percent, it's just 2%. And actually, I just noticed I did something. I should really put a plus or minus, right? Because we're talking about margin of error. So it's either above or below. So anytime you're writing margin of error, please remember to put those. Don't be silly and forget them like Mr. Masto just did. Okay, last 2 problems. Suppose a sample has a standard deviation of 106.4 and a sample size of 941. Find the margin of error to the nearest tenth. Okay, so this time I'm given a standard deviation. So when you're given a standard deviation, you want to use the equation 2 times standard deviation over the square root of n. Okay, so 2 times my standard deviation is 106.4. I'm going to divide that by the square root of my sample size, which is 941. And now this is easy. It's just a little bit of algebra. So if I multiply those on top, I get 212.8. And if I square root this, I get 30.676. Okay, and then if I divide those two, 676, I get that my margin of error is approximately plus or minus, right? Because we're talking about a margin of error. It rounded to the nearest tenth, so I've got 6.9, and we're done. I can change it to a percent if I want. I would just have to move the decimal place over 2, and then it would be 693%, but that doesn't really help me out, so we're going to keep it with 6.9. All right, last final question that I'm going to do with you guys. Oh, so sad. All right, Miss DeMassa recently took a trip around the world in her condo. The number of steps she walked from room to room was normally distributed with a mean of 115. If she walked 98 steps to the last room with a z-score of negative 0.5, what was the standard deviation? And this is like a true statement because remember I told you guys, right? Look. We're in the Ireland room right now. Oh yeah, so cool. All right. Ooh. Uh-oh. There we go. Okay. All right. So if I'm looking here, I'm going to use the equation z-score equals my data point minus my average over standard deviation. Okay. So I know my z-score. It's a negative 0.5. I know how many steps I took, my data, I walked 98 steps, minus my average or my mean is 115 steps, and I'm trying to figure out the standard deviation at the bottom. First thing I'm going to do is I'm just going to subtract these two numbers, and I get negative 17 over standard deviation. Now I want to get this sigma by itself, so I'm going to multiply it on both sides to get it out from at the bottom. Got sigma times, negative 0.5 equals negative 17. Then to get the sigma by itself, I'm going to divide both sides by negative 0.5. And I get that my standard deviation is 34, And we are talking about standard deviation is how far away I am from my average, and my mean is 115. I'm talking about number of steps. So my sigma should really be 34 steps. All right, gems, that is it. We are finished. I am done teaching you. You are now going to finish up your study guide, and then we've got our quiz over this on Thursday. You'll have Thursday and Friday to complete it. And then after that, the week after that will just be optional makeup activities. So if you want to make up, if you maybe didn't get a great score, you forgot to turn some homeworks in, anything like that, you will have an opportunity to make those up. I'm going to try my best to get them to you this week. But if you want to do those, you're welcome to. You do not have to do them. So if you finish this test, I put your grade in, and you feel really, really good about where you are, then you do not have to do those extra assignments. They are just there as kind of helps for people who maybe need some help with their grades. Okay, that's it. I am glad we had this chance to learn together. You guys were a fabulous group of individuals. I sincerely loved teaching you guys this year. If I don't get a chance to see you, wish you nothing but the best for your futures, especially if you're some seniors and I don't get a chance to see you. But if I do get a chance to see you, please feel free next year to come by and stop in and say hey. Otherwise, have a really wonderful rest of your year and have a really great summer. Make good choices. Love and miss you all. All right, bye guys.